Good morning. In this video, we will see how to modify the service demand using, rather than exogenous input data, a correlation. So the learning objectives uh, include the procedure to actually add a service demand using a correlation. As usual, we will download the files from the Zenodo platform. So here, that's the Zenodo platform, and we can see the relevant folders we are interested in, specifically with the default folders, which are going to download. This will contain all the relevant input data. What we will need also, okay, so here is it going to already to extract. Let me just go back to the downloads, right? Then what we will need is the macro drivers file. The regression parameters file, and finally the time slice share preset. Okay, so now we browse to the place where the files have been downloaded. We unzip the default file, the default folder. That's where we are. Let's have a look at what is inside. So we have the usual subdivision into input data with prices typically, and commodities, so the global settings file. Then what we are interested in is the techno data folder, which contains the definition of the sectors. Specifically, what we need to modify is contained in the preset folder. So in the current construction, the consumption file are read from here, and they inform the demand. So to keep our folders clean, we first delete the consumption file, and then we add basically the files that we are interested in. Sorry. Exactly, which are macro driver, regression parameters, and time slice preset. Okay. So at this point, we have performed all these tasks, and we just need to modify the TOML file, which is basically the file which governs the simulation settings. So let's go back here to the default folder. We open the settings file. I normally use VS Code to these changes. So what we see here is the usual structure of the settings folder, of the settings file. We can modify the current working directory into path to make sure that we are writing the results in the same folder where we are working. And then we move to the relevant section of the preset, which is down below. So it's down below to the file of the settings. So we just remove this section and we substitute it with the upload of the relevant files. So we save this. We save this. We copy the path. We open our Anaconda prompt. We make sure that we activate the environment where we are working. So in my case, my env. And then we just do a python -muse, paste the path and let it go. Okay, so it has started doing the initial settings check, building the sectors as you could see, and then it will start running the simulation from 2020 onwards. Now let's go back to the um, data file, so the platform where we downloaded the data from, and we can have a look while the simulation finishes at the files that we actually have substituted. So if we check the preview of the right, so we can check the preview. So it's a little bit slow. So essentially what we have here in the macro drivers file is the definition of the most important socio-economic drivers that would govern the demand of energy service. So it's GDP and population. In our case, GDP is in power parity, measured in million US dollar, and then projected from the time frame of inference of interest and beyond. The population is in million, uh, and then it's projected over the same time. We have region R1 as a reference for our study. The regression parameter is instead the file where we are defining for the selected sector the specific function with which we want to model. This is a logistic sigmoid function which is embedded in the model, and it's a transformation of the saturation part of a logistic curve. There we have a few coefficients, so a parameter which multiplies the GDP in the exponent of a function, a constant which multiplies basically the full regression function, and then a scaling factor for the GDP. These factors refer to the heat commodity, which is the one we are targeting for the residential sector. And this this function will basically define the annual service demand for the region. Finally, we can have a look at the time-slice share preset, which is the file where the selected region has for each commodity a definition of the split of the demand on onto the selected time slices, which are defined by Sn. And there are they go from 1 to 6 because that's representing the 6 time slices we are using in the model. So in this case, for all the commodities, we have 0, but for heat, where we have a selected allocation for each time slice. Now, these values are supposed to sum to 1, and they disaggregate the annual demand into the time slice value. Now, hopefully the model will have finished as that, and then we can have a look at the results. So there, we enter the results folder. What we are interested in is the file where the capacities are stored, and that's the MCA capacity, which collects all the capacity for each region, sector, and commodity over the time. So it is opening. Here we are. So now we insert the pivot table. And then we put capacity in the value, here in the row, technology in the column, and then sector among the filters, because we want to filter by sector. We are looking at the power sector, and that's where we have our results. So we just add a simple file which represent the growth. So we are growing our demand for electricity, and that's the result in an increased capacity for the power sector. This will conclude our exercise, and then I hope you will enjoy this video, and I will see you in the next one. Thank you.